All right, y'all. So 2.3 deals with finding domain and range. All right, so first I'm gonna go through what domain is and what our range is, okay? So the domain, and what we'll do, we'll start out dealing with domains of graphs, and then we're going to take it up a notch and start doing domains of functions. All right, looks like we got a bigger group today. All right, y'all, so I'm gonna start out with domain. When you're looking at the domain of a graph, the domain is the set of all x values. For the graph. Okay. Now, the range. So that means the range of a graph is going to be the set of all y values for the graph. Okay, so, and in this section, they're also going to use what we call set builder notation.
I have a question.
Okay, I hear you.
You did say if we however, if we miss anything on here, it is in the videos that we got, right?
Okay, say that one more time. I was breaking up.
Just say if you flip the page on me and I miss anything, it is in the videos, right?
Oh yeah, we're recording this. So usually about an hour after class, I get a video and I'll send it right to your email.
Okay, thank you. I saw it yesterday, so.
Mm-hmm.
Okay,
yeah, so everything we're doing here we'll have recorded. All right, y'all. So I'm going to start out by taking us to a problem that is a graph. And they want us to find certain things on this graph. So let me share that screen for us. All right, I'm going to zoom that graph in just a little bit for y'all. See all this question number A. From this graph, they want us to determine the following. So for A, they want to know what is f of -2. So what that question is asking us actually, they want to know what is the value of y when the x value is -2. So y'all, let's see, let's go to -2 on that graph for the x-axis. So you're going to go left over to -2 and go straight up until you hit that point. So what I want to know, and that is definitely a 3. So for this problem, since the x value -2 has a y value of 3, that means that f of -2 does in fact equal that 3. So then you would check that answer. So now they want to know the domain. So usually what I do on the domain is I go left to right. And all I'm looking for are the x values for each of these points. So y'all, the far left point on top of the V on the left, if you go straight down, you'll notice that that thing has an x value of -5. All right, the second point from the left, if you go straight down, that one has an x value -4. And notice you're just having to put commas in between each of these X values. And let me see, I got what, 1, 2, 3, 4. I got 7 points. That means I'm going to have 7 X values for this. So y'all, what's next?
-3.
-3.
All right, y'all keep me going.
-2.
Uh-huh.
-1.
-1.
Okay, yeah, I got a -1 there. Good job.
0,
0.
1.
And one more. That'll be 1. Good job. And just remember, that's all you're looking for when they ask for the domain or those X values. So we would put in them 7 values, check our answer. Now, y'all, this C part is the opposite of the A part. On A, they gave me -2 in place of the X. So I found the Y value. On C, they're telling us that f of x equals 5. So basically on C, they're giving me the Y value of 5, and I'm looking for any X's that have a Y value of 5. So y'all, if you go up to 5 on the Y axis
0,
and look at them X values. So you got one of them, you just said what?
0,
So I got a 0, but guess what? I got another one.
-4,
-4. So anything on that horizontal line going through 5 on that y-axis, that would have a y value of 5. And y'all got it, 0 and -4 were the 2 x values where that happened. So we'll check that answer. Now it wants the range. Well, the range is the set of all the y values. So that V in the very bottom, and usually I go from the smallest Y value upward towards the top, highest. So the V point on that, we want to know what that Y value is.
3,
All right. And then just keep going up. What's next?
4,
And y'all guess what? There's 2 points that have a Y value of 4, but we don't have to put it in there twice. We only got to put it in there the one time. All right, y'all. So it looks like we got a couple more.
5, and 6.
5 and 6. Okay, y'all. So remember, domain is my X's, range is those Y values. So then you just come down here and check them answers, and then we'll move to the next one. And I'm gonna actually do this one again on here. So let me make this graph a little bigger. All right, y'all. So we want f of 3. So what is the Y value when X is 3?
3,
Oh, that is definitely a 3. So I went over right to the 3, went straight up, and I hit the line at 3 on the Y values. So good job. Now look, since this one has got a continuous line on it, and it's got arrows on both ways, that means this graph is heading toward the left with the arrows off towards negative infinity. And towards the right, it's headed towards positive infinity. So that's what they mean by these arrows being on my lines. So when your line is continuous, heading in both directions, we say that our domain is all real numbers. So we would actually put E on that one, okay? Is that making sense, y'all? Since that line's going forever in both directions, okay? So then you would check that answer. So let me see, what's it saying? I'll continue down here. So how about this one? For what x values does f of x equals 1? In other words, for what x values do I have a y value equal to 1? So y'all go up to 1 on that y-axis and go straight across and see what you get.
5 and 7.
Yeah, I was going to say, I got two numbers there, it looks like, and y'all said them both. It looks like a 5 and a 7. All right, so now the next one's going to be the tricky one. They want to know, what is the range? But y'all look at this. The range is my y values. But notice, my y values don't go up and down. Both these arrows are going up. So what we want to know is, what's the minimum y value that we have there?
0.
0. And if you notice, my arrows are going up. So our domain is going to be greater than or equal to 0. So we would have to come down here and pick C on that one and then put in our 0. Okay, so notice the difference on that one and what was it, part B with the domain? Domain is the x's which went left and right. The range was the y values which go up and down, but on this one they only went up. So good job. So then y'all check that answer and move on, okay? All right, so I'm gonna go back to my pad now. So you'll have them graphs to look at for those problems, okay? But y'all, what we want to look at now is what we call finding the domain of a function. Now, the thing about the domain of a function, the domain of a function has to contain all the x values, so it must contain all x values for which the y values are real numbers. All right, y'all, let me pull my chat up real quick. I see a chat. Oh, okay, no problem. All righty, so it must contain all x values for which the y values are real numbers. Now, in this section, there's only one thing we're worried about as far as functions in which I won't get a real number answer, and that is fractions. And y'all, let me ask you this. There's only one number we cannot divide a fraction by. What is that number?
0.
0. Good job. Because remember, anything divided by 0 is undefined. And undefined is not a real number. So when we're looking at domains of functions, we are only concerned with fractions, since the denominator cannot equal 0. Okay, so if I got a function and I got a variable in that denominator, I got to try to figure out which numbers make that thing equal 0. Because if it does make it equal 0, I got to kick them numbers out of my domain, okay? All righty, so we're only concerned with fractions. So the domain must exclude all numbers that make the fraction undefined. Okay, so remember, I'm only worried about fractions. At this point, if we do not have fractions as the function, then the domain is all real numbers. So if it's not a fraction, that means I could put in a decimal, get a real answer. I could put an integer in there, get a real answer. I can put any number I want in there and get a real answer out of that, okay? So y'all, we're going to play with some examples and we're going to find the domain of each function. Okay, and I'll be using what we call set builder notation, and I'll show you that as we're going through this problem here. I'm gonna pull my camera down a little bit, get more space here. So for my first one, this is sort of like y'all's number 3 in the homework. They're giving me f of x equals 10 over x plus 15. So y'all, the one thing I'm worried about, I got on this problem. I got a fraction. So since I've got a fraction, I'm worried about any numbers that can be put in for that x that might make this equal 0. So y'all, to find those numbers, what you do, you're going to take this bottom of the fraction, the denominator only, and we're going to set x plus 15 equal to 0. That way, if we solve this, we can find out what values of x to kick out of our domain. You know, we just got one move on this. I'm going to get that x all by itself over here by moving to 15, by subtracting 15 from both sides. So I'm going to get my x. 15's cancel out on the left side. And over here, 0, negative 15 gives me a negative 15. So notice if I put that negative 15 in here, negative 15 plus 15 is 0. 10 divided by 0 is undefined. So we're going to exclude this negative 15 from our domain. So y'all, this is what we call set builder notation. You got your curvy parentheses. You tell them what the variable is. The variable is the x. So this is the variable. This little bar here, that little bar means such that. So we're telling it our variable is x, such that now we got to tell it what we're doing with our domain. So our x's can be a real number. And x cannot equal, well, what can it not equal? It cannot equal a negative 15. So we put in our negative 15 and then shut our parentheses. Now, MathLab will give you the parentheses and stuff. Usually they got it all filled out. You're just picking A, B, C, or D. So we tell it the variable such that X is a real number and X cannot equal -15. So any numbers we kick out, we're going to list in our set builder notation. So y'all got any questions on that? All right, how about this? And what if I had P of X equals 2X minus 10? So y'all, let me ask you this. Are there any restrictions on this domain?
Do we have to get X by itself?
Oh, no, you're doing too much work. So let me ask you this. Do you see a fraction?
No.
So remember, we said up here, if we do not have any fractions as the function, then the domain is all real numbers. That means no matter what I put in for that X, I can multiply by 2 and subtract 10, and I'll get a real answer out of that. So for this one, since we don't have any restrictions, our domain would be X such that X is a real number. So y'all remember one thing, fractions I'm worried about. Anything else, it's going to be a real number, okay? All right, so let me give y'all a second, then we'll flip over and do some more. Oh, y'all, how about one like this? This is my number 5. P of X equals X squared plus 7. So now I'm using the X squared on here. What's my domain? All right, I'm not even seeing my chat pop up. Let me ask y'all this. Do you see a fraction?
No.
So there's no fraction. So y'all, that means automatically this is going to be X such that X is a real number. Right, I can take any number you give me and square it and add 7 to it, and I'll still have a real number on that, okay? All right, let me keep going with y'all. G of X equals 4 divided by 4 minus 3x. So y'all, now I do have a fraction. And since I got a fraction, it's possible that there's a number I can put in for that x that makes this thing equal 0 in the bottom. And if that happens, I got to kick that number out. So y'all, since we got a fraction, remember, we're going to take the bottom of the fraction, 4 minus 3x, and set it equal to 0 so we can get that number. All right, y'all, so we're going to solve this. So y'all want me to move that 4, or do you want me to move that -3x?
A 4.
All righty, so I'm going to move the 4 by subtracting. So y'all, that cancels. I get my -3x is equal to what? A -4. And then we're going to divide both sides by that -3 and see what we get. Well, that cancels, giving me my 1x. Oh, y'all look at that. Them two negatives make that a positive. 4 divided by 3, we can't do nothing with. So we'll just keep that as a 4/3. Now in here, we don't have to turn these into mixed numbers. We can leave them as improper fractions, okay? So y'all, since I do have a number that'll make that equal 0, I'm going to exclude it from my domain. So we got x such that x is a real number. And x cannot equal 4/3. So do y'all see on these problems, when you're doing the domain of the functions, if it's not a fraction, automatically we're going to the real number. If it is a fraction, then we're going to find that number that we got to kick out of our domain. So let me throw y'all a little bit of a curveball here. Let's see what y'all do here. I got P of x equals absolute value of x minus 2. So what's my domain? All right, let me ask y'all this. Do you see a fraction there?
No.
So there's no fraction. So automatically, that means my domain is x, such that x is a real number. So if you notice, they all say the real number part. The only difference is if we're kicking out numbers, that's where we're getting that x not equal to whatever. But y'all, there's no fractions here, so we don't have to add the x not equal because it's good for all real numbers, okay? P of x equals, now this is on y'all, okay? P of x equals the x to the third minus 5. So y'all, the question of the day, what's that domain?
X to the third or just x?
Okay, it's going to be x, so we're going to start with our x such that
X is a real number.
x is a real number. So you'll notice on all the ones I did, the only ones where I put anything such as x not equal to a number was those fractions we had, okay? So y'all, that's 2, 3. Just getting you used to the domains on this, okay? So it's got like 8 problems. And they'll be really similar to these right here. So that's the thing you got to remember at this point. The only functions that we are concerned with on our domains are the fractions, okay? So y'all, we're about to have some real algebra fun now, okay? So let me move this one. All right, let me fix my paper here. All right, y'all, 2.4. Now this one will take a little bit longer probably because it deals with the algebra of functions. And in this section, there's 4 things I'm going to show you. So the first thing is what we call f plus g of x. f plus g of x means to take your f of x and add it to your g of x. So they're telling me if I got two functions, I add those functions, and y'all really, when you're adding, the only thing you can do is combine like terms. Okay. Second function, subtraction. F minus g of x equals my f of x minus my g of x. Really similar to adding, except for one thing. When you're subtracting a function, you want to distribute the subtraction. Then combine like terms. So it's sort of going back to that distributive property. If you got parentheses that follow subtraction, you distribute the subtraction to every term that's inside them parentheses. All right, next operation, multiplication. F times g of x will equal my f of x times my g of x. So this is the part where you'll either use the distributive property or we will FOIL these, okay? So a little bit of multiplication on that one. My last operation is division. F divided by g of x equals my f of x divided by my g of x. Let me ask you this. What can g of x not equal? Remember, there's only one number.
Zero.
Oh, there you go, 0. Because remember, if g of x equals 0, then we're not able to divide that. It'd be undefined, okay? So these are operations. If they give me f plus g, I'm going to write my f of x plus my g of x. F minus g will be my f of x minus g of x. F times g of x will be the f of x times the g of x. And then finally, my f divided by g of x will be my f of x divided by my g of x. Okay, so let's play with some of these and bring back memories of like terms and foiling and all that fun stuff. So y'all, given f of x equals x squared plus 1 and g of x equals x minus 2, they want us to find f plus g of x. Now I'm going to tell you this. When I start out, I'm going to bring out my f plus g of x. I always use parentheses to put my functions into. So remember, f plus g of x is my f of x plus g of x. So this will be my f of x plus my g of x. And I'm just going to put my functions in here. F of x was x squared plus 1. G of x was x minus 2. Now remember, we're not doing nothing to this left side. That's just symbolism letting us know what we're doing. All we're going to do is play with the right side. Now, when you're adding, you can drop these parentheses and leave everything the same sign. So I'm going to drop the parentheses and I get an x squared plus 1 plus a x minus 2. Y'all, the question is, can I go any further?
One minus two.
Yeah, that 1 minus 2, those are like terms. So we do got like terms there. So I'm just going to put them in what I call descending order. I'm going to go with my x squared first. Then I'll bring down that x right there. Then how about that? 1 minus 2 would give us what? A negative 1. At that point, y'all, I cannot go any further. So that would be our final answer. So adding, basically, drop the parentheses, combine like terms, and be done with it. Any questions on that? All right, given f of x equals x squared minus 4. And g of x is going to equal x minus 2. They want us to find f times g of x. So y'all looks like they got a little multiplication here. So we're going to bring down our f times g of x. It's going to equal my f of x times my g of x. So let me put in my f, which was what? X squared minus 4. My g was x minus 2. So we're just going to play with this right side again. But y'all, I'm multiplying 2 things times 2 things. This is where we're going to have fun by foiling that. Y'all familiar with your foiling? All right, well, here we go. We're going to foil this. So to foil this,
It's been a while.
do what now? It's been a while. Well, foil just lets me know that I got to multiply 4 things. So the
First, outer, inner.
Uh-huh. And basically
can't
what that
remember.
means is this x squared times the x. That's the first ones from each parenthesis. So y'all, what happens when I multiply x squared times the x? Now
X
remember,
cubed.
x cubed. Because remember, since this x don't have an exponent and it's like a 1 there, and all you're doing when you multiply the letters is you're adding those exponents. All right, the outer is the 2 outermost. That's the x squared times the negative 2. That's going to give you a negative 2x squared. So my first, my outer. Now the inner, I'm going to be starting with the negative 4. The inner gives me a negative 4 times x, which would be a negative 4x. L is the last ones from each parenthesis, so that'll be the negative 4 times the negative 2. So let's see, negative 4 times negative 2 is what? A positive 8. So take the x squared, multiply by both of those. Take the negative 4, multiply both of those. Remember, I got 4 things now. So my question is, can I go further with that problem?
No.
No, because I do not have any like terms. So see, today you're getting to do a little more algebra today, okay? So let's see what they did here. Given f of x equals x squared minus 4 and g of x equals x minus 3. Y'all watch this. They want me to find g times g of x. So y'all, guess what? G times g of x is going to be my g times my g. So they're sort of throwing you a curveball, giving you the F on this one at all. Because this is a g times g, which would be a x minus 3 times x minus 3. So you got to go by what they're asking for to put in here for your multiplication. And guess what? 2 things times 2 things. We're going to FOIL that again. All right, y'all. So here we go. The F is the first ones. So that's the x times the x. We're going to get an x squared. Then we're going to take that x and do the outer, which is at -3. So x times -3 is a -3x. So my inner is now going to be the -3 times x, which is a -3x. And y'all, the L is the last ones. That's the -3 times -3, which gives us a +9. So this one sort of gets people sometimes, but y'all, what would my final answer be?
X squared minus 6x plus 9.
Perfect. What happens is sometimes when people see these -3x's matching, they try to cancel them out, but you did good. They're both negative, so you just add them together. Good job. Don't cancel them when they got the same signs. All right, y'all, so let me let y'all write that, and then we'll flip the page. So this is that algebra y'all was waiting on, right? Instead of on the graphs. All right, so let me try something different here. What if I give us let f of x equal, so let me pull my paper back up. All right, so it's back up now. So we're going to let f of x equal, let's say, -8x plus 11. And my g of x is going to equal x squared plus 18. But y'all watch what they want. They want me to find f of 7 plus g of 7. So let's see what we're going to do here. So f of 7 plus g of 7 will equal my f plus my g. But y'all guess what? My f is -8x plus 11. But that's not what I'm going to put into these parentheses. Because look here, they're putting a 7 in place of the x. So that means they want me to put a 7 in place of the x in the f equation. So when you come down here, you're going to have -8 times 7 plus 11. So that's now f of 7 because I put a 7 in for its x. Same thing with your g here. They got g of 7. So g of 7 will be 7 squared plus 18. All right, so I'm going to work in the parentheses for a little bit. Since they're giving me numbers, I'm going to get this down to a single number, that down to a single number, then I'm going to add them. So, the first thing we got to do up here is multiply -8 times 7. So that's going to give us a -56 plus our 11. 7 squared plus 18. Well, 7 times 7 will give me a 49 plus my 18. So all we're doing is inside of each one of the parentheses, we're sort of following that order of operations still. Now, if you notice, once I add these, I'll get a single number. So I'm not going to need those parentheses anymore. So let's see, what is a -56 plus 11?
-45.
So a -45. And then over here, we got what, a 49 plus 18?
67.
67. All right, so my final step is to figure out what that 67 and that -45 will give us. Oh, and that's what, 20 something,
22.
22, there you go. And 22 is our final answer. So y'all, if they give you numbers, you're going to come up with a number for that answer. If they just throw X's in there, then all we can do really is add like terms and do stuff like that, okay? All right, y'all, question on that? All righty, so let me try another one with numbers. How about we're going to let f of x equal -13x plus 14, and g of x is going to equal x squared plus 7. What they want me to find this one, they want me to find f of 10 minus g of 10. And I'll tell you the truth. They could have said f minus g of 10, and that would have told me to put a 10 into everything like this is. But yeah, either way. So we're subtracting. So f of 10 minus g of 10 will equal my f minus my g. And remember, in place of both these x's, I'm going to put that 10. So this will give me -13 times 10 plus 14. And this one is what? 10 squared plus 7. So to me, the thing that makes a difference on these problems is getting this set up in the beginning. Because once you got it set up, you're just playing with order of operations, okay? So I'm not going to be able to get rid of parentheses on the first move. So -13 times 10 is what, a -130 plus my 14. Over here, 10 squared, 10 times 10 is 100 plus our 7. All right, so I'm going to get this to a single number, and then I'll do my subtraction as my last step. Whoo, y'all, I got a big one here. -130 plus 14 is what, a negative
140?
oh, what'd y'all just say?
Is it 140?
Oh, my -130 plus 14?
-116.
116, there you go. So remember, since they're unlike signs, subtract and get a sign of that larger number. Now that'll be minus 100 plus 7, which is just 107. All right, y'all. So negative 116 minus 17 is like you're adding two negatives. So no matter what, this answer will be negative. And let's see what I get. I get
223.
23. Good job. Okay. But I'm not going to lie. At this point, right here, y'all could have put that exactly into the calculator like it looks. And that calculator would have spit out negative 223 really quick, okay? All right, so I'm going to try one like this one. Let's see. We're going to let f of x equal negative 5x plus 9. G of x is going to equal x squared plus 16. I just want to pull this down a little bit. So what they want me to find on this one, they want us to find f of negative 4 divided by g of negative 4. So they're wanting us to do a little division on this one, okay? So f of negative 4 divided by g of negative 4 will equal my f equation divided by my g equation. Now remember, I'm putting in a negative 4 for the x's. So on top, I'll have a negative 5 times negative 4 plus 9. On the bottom, I'll have a negative 4 squared plus 16. Y'all, let me emphasize this. Negative numbers that have exponents, I would definitely put them into parentheses, especially if you're using that calculator. Because remember, negative 4 times negative 4 should give me a positive 16. But if you put negative 4 and squared on the calculator without parentheses, it'll give you negative 16. It will not square to negative unless it's in those parentheses, okay? Also, if I was to put this into my calculator, I would be putting extra parentheses around the top and the bottom so that the calculator knows what's being divided by what. Unless you use the alpha y equals. If you use the alpha y equals, you don't have to put the parentheses because remember, alpha y equals makes it look like a parentheses. So let me share that and I'll show you what I'm talking about. So remember, on the calculator, if I want it to look like a fraction, I'm going to hit the green button and the y equals and hit enter. And then I can just put my negative 5 times my negative 4, close parentheses, plus 9. Then I would arrow down to the bottom. Now remember, since I got a negative 4 being squared, I'm going to put that negative 4 in parentheses, close the parentheses, and then square it. And then I'm going to do my plus 16. So if you use the alpha y equals to get the fraction, in this method, you don't have to use the extra parentheses, okay? So now we're going to hit enter, and it'll give me my answer as a fraction since I put it in as a fraction. And y'all, I get what? A 29 over 32. Okay, so on top, negative 5 times negative 4 was 20. 20 plus 9 gave me 29. On the bottom, negative 4 squared is 16. And then 16 plus 16 gave us that 32. So yeah, on them kind of problems, I really, really, really like using the alpha y equals to make it look like a fraction. All right, y'all, so let me fix my paper here. I'm going to try a little subtraction here. How about this one? Given f of x equals 9x minus 5 and g of x equals 3x minus 6, I want to find f minus g of x. All right, so no numbers are going in this time. So f minus g of x will equal my f equation minus my g equation. So y'all, my f is 9x minus 5 minus my g is 3x minus 6. So this is one where in the beginning I said, if it is subtraction, we got to distribute that subtraction to both of these when we drop these parentheses. So we're going to distribute that subtraction through the parentheses. So nothing in front of the first parentheses, I can drop them and leave everything the same. All right, y'all. So if you distribute that negative, what am I bringing out? So what's this going to give me? A negative times a positive is going to make that a negative 3x. And then this negative times a negative is going to make that a positive 6. So you treat subtraction like a -1, and you're just multiplying through the parentheses. So y'all, at this point, can we go further?
Yes.
All righty, so what we doing?
Combining the 5 and the 6 and the 9x and the 3x.
Oh, perfect. Two sets of like terms. Good job. So let's see, a 9x minus 3x, that's what, 6x. And then you said the -5 and the 6, would that be a +1? I don't even see my chat, it lit up too. So combining like terms, good job. All right, y'all, and at that point, no more like terms. So final answer. So here's something they do once they figure out, hey, they're starting to get the hang of this. Here's where they try to throw us a curveball. F of x is going to equal, oh, how about x squared minus 3? G of x is going to equal 12 minus x. Now y'all watch this one. They want me to find f times g of n. So here we go. F times g of n will equal my f equation times my g equation. So here's my question. What am I putting in for my f equation? What do y'all think?
X squared minus 3.
Oh, you're really, really, really close. But what do they got in them parentheses?
The N,
Uh-huh. So you're going to replace that X with an N, which will give you a N squared minus 3. And then what are you putting in the second one?
12 minus N.
12 minus N. There you go. So basically, I'm still dealing with variables. It's just that my variable is now an N instead of the X, okay?
Why is it an N instead of the X?
Oh, because look right here, they put that N into our parentheses. And remember, we said anytime you got function notation and you got anything else other than the variable in the parentheses, they want me to take that in and put it in for all these X's. Sort of just like we did with those numbers a while ago. Remember when I had a 7, I put a 7 in for my X's. So same thing, they're just trying to be cute and trying to throw you curveballs. So now 2 things times 2, we're going to FOIL. So guess what? If I'd have put an R here, then this would have been an R squared minus 3, 12 minus R. It depends whatever they're putting into them parentheses, okay? All right, y'all, so here we go. N squared times 12 is a 12N squared. How about this? N squared times a negative N. That's a negative what?
N cubed.
N cubed. So there you go. That's like a 1 again. All right, now we're going to go inner. So negative 3 times 12 is what, a negative 36. And then that negative 3 times that negative N is a positive 3N. Now, y'all, although this one does not have any like terms, they want us to put this in descending order of exponents. So that means you put the highest exponent first, then the next highest, then the next highest, and then your number at the end. Now, when you rearrange these, since that's a negative N third, that has to stay a negative N third when you rearrange it. Then you got a positive 12N squared. Let's see, what was next? A positive 3N. And then minus my 36. So they want me to go from the biggest exponent, next, and then my number, okay? So watch for that when they say they want these in descending order. All right, y'all, how about we take us a little break? How about a 10-minute break, and then we'll get out and we'll finish out this 2.4, okay? I'm going to stop my recording for a second and pause it. All right, and get my screen shared. All right, y'all, so this next problem, they're going to give us 2 functions. So for this one, they say for the functions f and g, determine the domain of the sum, difference, and product of the 2 functions. So we got a domain problem here. So they're giving us f of x equals x squared. And g of x is going to equal 9x minus 9. So they want me to find the domain of the sum of these functions, the difference, and the product. So let's start out with the sum. So that would be f plus g of x. That'll be my f plus my g. So my f is x squared. My g is 9x minus 9. So any guesses on that domain? So remember, there's only one thing I'm worried about in a domain, and that is fractions. So y'all, we don't see any fractions here. So I can put any number I want in for these x's. I will get a real number answer out of that. So that means my domain is going to be x such that x is a real number. So just like in 2, 3, if you don't have a fraction, it's automatically going to be all real numbers, okay? So that's the domain of the sum. So the difference will be f minus g of x. So y'all, that's going to equal my f minus my g, which will be the x squared minus the 9x minus 9. So y'all give me that domain. Remember, y'all can chat that also.
X such that X is a real number.
All right, perfect. So how about our product? That's our multiplication. That means f times g of x will equal my f, which is x squared, times my g, which is 9x minus 9. Any guesses on that domain?
Is it 9?
Well, remember, if you put a 9 in here, you can square 9, and then you can put a 9 in here and multiply and subtract, and you'll still have a real number.
So is it 1?
Well, let me ask you this. Do you have a fraction here?
No.
So guess what? Since I don't have a fraction,
X such that X is a real number.
x such that x is a real number. There you go.
I'm so sorry. I'm so clueless. Where did you get that from?
Excuse me?
I said, I'm so sorry. Where did you get that from?
Well, remember when we was doing the domain earlier, we said the only domains we're worried about excluding any numbers from were the denominators of a fraction. If you don't have any fractions here, we said the domain automatically is going to be all real numbers. Any number you give me, I can put in for them x's, and I'm going to get an answer out of it. But remember, if I had a fraction, fractions we worry about because fractions we cannot divide by 0. So if we got a denominator of a fraction and it equals 0, we automatically kick any of those numbers out. But if I don't have a fraction, there's no restrictions, and it's going to be for all real numbers, okay?
Oh, so if it's not a fraction, it can be all real numbers.
It's
period.
got to be all real numbers.
Okay.
Okay. So I will give you a fraction on this one so that y'all can see the difference. So I'm going to do the same thing. I'm going to determine the domain of the sum, difference, and product of my two functions. So my first function is going to be f of x equals 1 divided by x minus 5. And my g of x is going to equal 6x to the third. And I'm going to do the same thing again. I'm going to find the domain of my sum, my difference, and my product. So I'm going to start with the sum. F plus g of x equals my f plus my g. So that'll be 1 over x minus 5 plus my g, which is 6x to the third. So will this one be all real numbers?
No.
No, because y'all, I do have a fraction on this one. So since I have a fraction, member, I'm going to take that denominator, x minus 5. I'm going to set that equal to 0 so that I can find what number I need to exclude. So y'all solve this by what? Adding the 5 to both sides? So I get x equals 5. That means if you put a 5 in here, 5 minus 5 is 0. 1 divided by 0 is undefined. So that means I need to exclude this 5 from my domain. So my domain is going to be x such that x is a real number. And x cannot equal a positive 5. So only time I'm writing a number here is when I do have a fraction that has a variable in that denominator. So y'all, let's do the difference. That'll be f minus g of x. So my f, which is 1 over x minus 5, minus my g, which is 6x to the third. Any guesses on that domain?
6.
Oh no, where y'all getting a 6 at?
Oh, I'm so sorry. I was looking at the parentheses. I'm so sorry. I just took a guess at it. I didn't really know.
So let me ask you this. The only thing we're worried about, remember, is this fraction. So what number would I put in for that x that'll make that equal 0?
5.
5. Because remember, 5 minus 5 is 0. 1 divided by 0 makes this undefined. And y'all, we can't do nothing with undefined. So since 5 is the only number I'm worried about, I'm going to do x such that x is a real number. And x cannot equal a positive 5. All right, y'all. So we got the product next. That's going to be f times g of x, which will equal f, which is 1 over x minus 5, times g, which is 6x to the third. Any guesses on that domain?
Same
Different,
thing,
just
right?
the same.
It's exactly the same. Because the only
Wait,
thing,
I'm so sorry. How is it the same?
well, you only got one fraction here. And
Just
there's only one number that'll make that fraction undefined. And that is a 5 in the bottom. Because 5 minus 5 makes that a 0, remember? And I cannot divide by 0. So if you notice, all three of these had the same setup. 1 over x minus 5 plus that, 1 over x minus 5 minus that, 1 over x minus 5 times that. But this x minus 5 is what's giving me the issue, because when I put that 5 into there, it makes this thing undefined. Okay? Any other number you give me, I can put in for that x, I can put in for that X, and I'm going to get a real answer. It might be a decimal, it might be a fraction, but it will be a real number, okay? We're looking for things to exclude that give me things that are undefined.
Oh, so you're looking for things to make it undefined.
Yeah, whatever makes it undefined, and then see, we're putting that not equals, because we're telling it, hey, my X cannot equal that number because it made that thing undefined, okay? And if you notice, the sum difference and product all had the same answer up here. The sum difference and product all had the same answer down here. Okay, no matter whether you're adding, subtracting, or multiplying, those domains are going to match every time. So let me actually give you one that is division. So let me see my page here. So y'all, for this example, they say for the pair of functions, f and g, determine the domain of f divided by g. So they're giving me f of x equals 7x minus 10. And my g of x is going to equal 10x minus 30. So let's figure out this domain. So f divided by g of x will equal my f, which is 7x minus 10, divided by my g, which is 10x minus 30. So let me ask y'all this. Will my domain be all real numbers?
Yes.
Yes.
Will you have to exclude any numbers?
No.
Oh,
Do you combine like terms?
well, so what are y'all going to combine? Because remember, these
The
are,
-10 and the negative and the positive, or yeah, -30 and the -10.
well, but remember,
Or-
these are being divided, so you really
Oh,
can't-
yes, you would divide them. Okay.
Uh-huh. So here's the thing. Remember, the bottom of this fraction cannot be a 0 because that makes that undefined. But I got a variable down here. So what you're going to have to do to this, you're going to have to set 10x minus 30 equal to 0. Whatever answer we get means we're going to exclude it because that made this equal 0 actually, okay? So y'all, let's solve this. So we're going to add 30 first to get that 10x by itself. So now you're getting 10x equals 30.
3.
So divide both these by 10. And what did you say we got?
3.
Yeah. So you get x equals 3. So if you put a 3 in for this x on the bottom, 10 times 3 is 30. 30 minus 30 makes this equal 0. Well, if that makes that equal 0, that's going to make this whole thing undefined. And remember, undefined is not a real number. So anytime you got a fraction that does have a variable in the denominator, you got to see what number makes it equal 0 so you can throw it out of the domain. Now, I'm not worried about the top. The top can equal 0 all day long. You can do 0 divided by 1, 0 divided by 2. You'll get 0 for that answer. But anything divided by 0 is what's making it undefined. So for this one, since 3 made that equal 0, our domain will be x such that x is a real number and x cannot equal a positive 3. Because if x equals 3, it made it undefined, okay? So y'all, that's the world of the domain. So what questions y'all got?
Well, sir, I was frankly confused by the whole entire thing.
Okay, so let me show you what I'm talking about. So let me break this out. Maybe this will explain it. And we're going to do a graph here. So what I'm going to do, we're going to graph, and we're actually going to graph something that looks like a fraction so that y'all will see what I'm talking about. So how about we're going to graph f of x equals, oh, how about something simple like 1 divided by x. So let me make a little graph over here. So that's my x and my y. And I'm going to go out about 5 on it. Because y'all got to understand this domain, because that's a big part of this class. So I'm just going to make me a little table up. I'm going to pick me some x values, put them in my function, and plot my points, okay? So I can do a -1 for my x. So let's see what we get. 1 divided by -1 is -1. So when my x is -1, my y value is -1. Y'all give me some numbers. What's another number?
+2.
Yeah, I can use a +2. And that'll give me 1 divided by 2, which is a 1/2. So when x is 2, my y value is 1/2. So that's about halfway up. All right, give me more numbers.
Four.
All right, so I can use a 4. 1 divided by 4 is a 1/4. So over here at 4, it's getting even littler. All right, so y'all don't go no further that way because I'm going to be getting too big of numbers. So focus in this middle here.
-2.
So I can do -2. 1 divided by -2 is a -1/2. So over here at -2, you're about a -1/2. All right, so I could do a 1. 1 divided by 1 is 1. So when x is 1, well, y is 1. How come y'all ain't picking 0? Well, let's see what happens when I pick a 0. I'm going to pick a 0 for the x. Well, y'all, what does 1 divided by 0 give me?
0.
Oh,
Oh,
undefined. There you go. So let me ask you this. How are you going to graph this? At 0, we can't graph undefined. There's not an undefined point on here. So you see, any number y'all give me, I can graph except for the one where the bottom equals 0. Since 1 divided by 0 was undefined, I cannot graph that. So this graph will not cross over that 0x value at all, okay? Any other number you give me, I can put on here somewhere on that graph. But the only number I cannot plot is when that x equals 0. Does that make more sense?
Somewhat.
Yeah, and look at this one. Let's try this one. Let's do f of x equals, how about x squared? I'm gonna draw me a graph real quick. All right, so I'm just gonna pick a few x and y values on this. So y'all, I can do a -1 on this. -1 squared is -1 times -1, which is 1. So at -1, I got a 1. I can do 0. 0 squared, 0 times 0 is 0. I can do a 1. 1 times 1 is 1. But do you notice any number you give me, I can square it, can't I? You can give me fractions, I can square fractions. You can give me decimals, I can square decimals. Any number you give me to put in for that x, I can get a y value. And when you graph it, these are the ones that made the, what we call the parabolas. So notice the difference. Any number you give me, I will get an answer out of this one. This one, if you put me a 0 in for that x, I don't get a number, I get an undefined. So that's why on this one, up here my domain would be x such that x is a real number and x cannot equal that 0. It can't equal 0 because it made it undefined. Down here on this one, well, I don't have any restrictions. Any number I can put in there, I can multiply times itself and get a y value. So this one's domain would be x such that x is a real number. So that means it works for all real numbers. I don't have any restrictions, and this little graph will just keep going and going forever. All righty. So they're just tricky. You just got to play with them. And remember, when y'all are doing my domain problems, the only thing y'all are worried about is the denominator of a fraction. You don't care about the top, just that bottom, okay? All right, y'all. So, any questions from anything? Any homework issues that are bugging y'all?
I did have some until now, but I'm okay now.
Okay. So someone's asking, is this homework? Yeah. So support is required. Now, every section don't have a support homework in front of it. Some do, and that's just to get you a little stronger for some of the skills you're going to need for the actual college algebra. Usually the support assignments are fairly small compared to my college algebra part of it, okay? So did y'all have any support questions from 2-1 and 2-2?
So there was a problem on the homework last night, and we went over it yesterday during class, and the answer was -13. But on the
I know what.
actual,
So here's the thing. So you was doing the F of C. So let me write this down. Let me share my screen. So that one I think you're talking about was F of C equals what? Y'all remember the formula?
9/5C. plus 32.
plus 32. Now, when I did it, they gave me C equal to negative 25. So let's put that negative 25 in and see what we get. So we're finding F of negative 25. So I have 9/5 times negative 25 plus 32. And remember, I showed you all the tricks I did. That negative 25 divided by 5 made that a negative 5. So then I multiplied 9 times negative 5 was what? Negative 45. Bring down my 32. And when I added that, I got a negative 13. So here's the difference on this. You had not a negative 25, but a positive 25. So let's see the difference when I put a positive 25 in here. You're going to have 9/5 times 25 plus 32. So the difference was, since this was positive, when you divided 25 by 5, that made it actually a positive 5 instead of that negative 5. So we'll multiply. 9 times 5 is 45 plus my 32, which these were both positive. So when I added them, I ended up with a 77. So I think what was getting you was mine was negative and yours was a positive 25. Does that make sense?
Okay, I see it now. I guess my brain skipped over the
Oh, that's
first
all right.
one.
Because yeah, it looked exactly the same, and then I was looking at it and I was like, oh, okay, because I looked at your problem it sent me, and yours was actually positive, so that's why you should see 77 as one of your answers.
I actually have a quick question about the homework.
Uh-huh.
You said there's like two parts of it. I forgot what it's called, but is the reach part like important? Like the
How about you talking about the support stuff?
is that one required?
Yeah, so y'all are doing college algebra with support.
Oh, okay.
So the support is taking place of y'all having to take transitional algebra for a whole year and all that stuff. So the support part only has homework. It has no quizzes, no tests or anything. It just counts toward the overall homework grade for the class. And y'all, let's play with some of these, see what y'all would do with these. So y'all should have had an assignment 2.2 that looks like this one. So let me see if I can zoom this in. And then focus that in. All right, let me see what my chat's saying here. Yeah, so yeah, negative 30. On that one, if I'd have done a negative 30, let me show you what I've done real quick. So F of a negative 30 would have been 9/5 times your negative 30 plus 32. But I do notice they're giving you all multiples of 5 here so that they will divide. So when I divide that negative 30 by 5, I get a negative 6. So 9 times negative 6 would give me a negative 54 plus my 32. So that's what a negative something. So that's what a negative negative 22 for that one. So they're going to throw you all a few curveballs on that, but it should be a multiple of 5 so that it will divide by this 5 on bottom. And then you're going to multiply, add, and be done with those, okay? All right, so this is an example of the support from last night. And y'all, this was just so that you would be able to do the stuff I did today. So let me ask y'all this. What does n minus 11n give you?
Negative 12 then, or negative 10 in.
Negative 10n, perfect. Okay, so 1 minus 11 gave me negative 10. The n stays the same. Y'all, one golden rule you got to remember. when you're adding and subtracting, do not change those variables, okay? So how about this one? 10C plus 7C minus 11C.
6C.
6C. Now, you remember when I was doing the subtraction today, I said you had to subtract that negative. So this was a case showing you how to do that to get you ready. Subtract that negative. So that negative times that positive C gives me a negative C. That negative times that negative 10 makes that a positive 10. So y'all get this one. What am I going to put on this one? I got a negative outside times 16A plus 4B plus 95. What's that giving us?
Negative 16A minus 4B minus 95.
Perfect. And if you notice, all these negatives do is change all the signs from the inside to the opposite. So then here, you got a 9A. Well, the 9A is not in parentheses. So the 9A is going to stay the same. But then we've got to distribute the negative through the parentheses that follow. So that's going to give me a minus 2A minus the 7. Can you go further?
7A minus 7.
There you go. 7A minus 7. So always look to see if you can actually add those like terms together. And y'all, that's all these are doing, was just getting you used to distributing and stuff. Don't worry about stuff in front of parentheses, only the stuff in the parentheses. So this one, you'd have a 9D minus 7 minus 2, and then plus 3D. And then you're going to add like terms. So the 9D and the 3D give you 12D. The negative 7, negative 2 give you a negative 9. And you know, the same thing here, you would distribute so let's try this one. You would bring down the 8x, distribute the negative 6 times 2x, that's going to give you a negative 12x. Distribute the negative 6 times the negative 3, that's going to give you a positive 18. And then outside is a negative 3. So we're only distributing the stuff in front of the parentheses to the stuff inside the parentheses. And at the end was my minus 3. Over here, I would start adding like terms. So 8 minus 12 would give me a negative 4x. 18 minus 3 would give me a positive 15. So y'all, let's try this one. On this one, I'm going to distribute a 1/4. So basically, when you're distributing a 1/4, it's like you're taking both of these numbers and dividing by the 4. So the 4th of a 32, y is a what? It's an 8y. So 32 divided by 4 would give me 8. Over here, a 4th of an 8 would be the same thing as 8 divided by 4, which is 2. Now look here, you got a negative 1/2. We got to distribute the negative also. So this one's going to be a negative times a negative, which is going to make that a positive. So what's a half of a 6y give me?
Is it 3y?
3y.
3y, perfect. And then a negative times negative is going to make this one positive. So what's a half of a 2?
1.
And then at the very end, notice it's sitting a minus 14. So when you're doing something 1/4 times a number, that's just same as that number divided by that bottom. 32 divided by 4 was 8. 8 divided by 4 was 2. -6 divided by -2 was 3y. -2 divided by -2 was a +1. Then I brought my 14 over. And then I'm just going to add like terms. I got the 8y and the 3y gave me 11y. 2 plus 1 is 3. 3 minus 14 is what? A negative 11. So the whole trick with this homework was to get you ready for my subtraction today and my FOILing and all that fun stuff. Adding like terms and trying to simplify things as far as you can.
So with like terms, why do you multiply like the 1/4 times the 32y? Why does the 1/4 not have to be a y to be able to, is there a rule or something?
No, so the only rules are, so check this out. When I'm adding and subtracting, that's when I'm worried about the y's. X's add to x's, my y's add to my y's, my d's add to my d's. I can add stuff as long as they're like terms. If they're not like terms, I'm going to leave it like this, -4x and 15. Can't go no further if they're not like terms. But y'all multiplying, I can multiply anything times anything I want and get a product. I can multiply my numbers times my y's. I can multiply y times y. I can multiply x's times y and just end up with x, y's, but I can multiply anything I want times anything else. The only thing that math is really, really picky about is adding and subtracting have to be like terms. Does that make sense?
Yes, sir.
Okay. So yeah, like we was doing while ago with that FOILing, remember we had like x plus 3 stuff. We had x plus 3 times maybe x squared plus 2. Notice when I multiplied, I didn't care what was here. I just multiplied it and wrote it out. So my x times x squared, I ended up with an x3. X times 2, so notice there's a number times an x. That gave me a 2x. Here, I got 3 times the x squared, which will just give me a 3x squared. And then finally, my 3 times 2 gave me 6. So notice, any of these things, I can multiply and get stuff. But at this point, where they're all being added, can I go any further with this one?
No.
No, because x3s don't add to x's, which don't add to x squareds, which don't add to numbers. So we're only really, really picky, y'all, when it comes to that adding and subtracting, okay? All righty, anything else bugging y'all?
I have a quick question. Are we gonna have a a quiz or a test at the end of this week?
So this week we're just going to go through the material for test 1. Next week, now the quiz is open for test 1. Y'all's quizzes are only going to be those test review quizzes that are like 20 questions, 25 questions. Those are the only quizzes. And what we'll do Monday, we will start reviewing for test 1 and go through that review guide. Now, the reason you want to do the review is because those reviews look just like my test. Okay, so it'll be the same questions that are on that review that you're going to have to worry about for your test. And you can do the review as many times as you want, but you only get one chance on the test, okay? So, yeah, so we'll finish the test one material Friday, but y'all will not have to worry about the test. I'll open it up next week and it'll be due that next Sunday. So someone's saying, when the course actually ends, the last day of class, the final will be due on June 29th at midnight. So that's like a Thursday on our 5th week. After that time, you will have
You
no
said-
more access.
You
I'll go
said,
figure out your final grades, put them in the portal by that Friday, June 30th.
you,
I hear you.
you said something, you said it's June the 5th?
No, June 29th is the last day. On June 5th, well, all of y'all have been online, so you don't have to worry about it. But June 5th, if you look in the homework, when your first assignment is called a course agreement, it's not math related, it's just questions about financial aid and
Oh.
stuff like that.
Oh, no, I thought you said we had a test June the 5th, something.
No, you just have to have that course agreement done by then.
Oh, okay. Oh,
But that's only for the people that aren't getting online. If you're getting online, we actually count that as attendance. And this is all due, if you don't report to class or do any work by June 5th, we drop you, which
Okay.
affects your financial aid.
okay.
But since all y'all been in my class, y'all attended, so y'all are good to go.
Okay.
But it'll make you do that before you even touch my homework. It should make you do that course agreement first. If you try to click on the homework, it should say, well, you can't do it yet. You didn't do your course agreement or whatever. I think it was what, 5 questions, and you can only answer one
Yes.
answer on it, right? You can only agree to everything, I think. So yeah, once you get through that, that's what some people don't show up for class, but they can do that course agreement and it counts as them being in class, I guess.
Oh, okay.
Do you also have to have 100 on all the homework before we continue?
No, you don't have to have 100. It helps your grade out, and you can do any homework problem as many times as you want to get it right. But no, you don't have to score 100 on anything. The only thing you had to score 100 on was that course agreement thing. Okay.
Oh, okay. I misunderstood that one. Thank you.
No, we want y'all to get hundreds because that homework, since you can do it anytime you want and fix anything, you can come back at the end of the year and say, oh, I know this now, and come back and fix homework from the first part of it if you want to. Now, at the end of the year, I will drop 2 low homework grades out. So if there was a homework you couldn't get to or you just didn't understand, it'll drop off at the end of the year. And then I'll drop off one of those 4 quiz grades. So at the end of the year, my scores usually start jumping up and stuff once I start dropping tests and, well, not a test, but dropping the homework and stuff like that. Now, remember, on a test, if you make a really bad test, I'll replace the lowest test with the final exam score, which sounds scary, but I usually get people doing better on the final exam than they do my 4 tests. In the final exam's multiple choice, it's not even, these 4 tests, they'll have you putting in the answers, writing them and all that, like the homework. But y'all, that final exam, ABCD, all the way through it. So if one of them answers works, punch it and go, okay? All righty, y'all, do I have any more questions? Anything y'all need help on? If not, I'm going to let y'all go. And I will see y'all, what's today? Today, Wednesday?
Mhm.
So if there's no questions, I'll see y'all Thursday.
Okay.
Are we not doing the support today if we don't need to?
Oh, support is just if y'all need any work with me,
Okay.
like going over any of these homeworks and stuff. It's not actually like a lecture. So what I usually do, once I let y'all go, I'll leave my Zoom open. If y'all got any questions, pop in on it, ask me something or whatever. But we're not going to keep y'all here just boring you for another hour, okay?
If we do so happen to actually have a question on one of the homeworks, is it possible that we could share our screens so you can see what we're working on?
So yeah, so what you want to do, if you do have a problem on homework, pop up on my Zoom and it should notify me. I'll come in. I can enable you to share screens. Let me make sure. Yeah, so I got it where it says multiple participants can share their screen. So do y'all see a share button on your Zoom now?
Mhm.
Yes.
So what we'll do is if you need to, you can share your screen. I can see your problem exactly. And we'll figure out what we got to do.
Okay, that sounds good. And that's usually at what time, if you don't mind me asking? Like,
That starts at 12 and ends at what, 12:45 or 1 o'clock, something like that.
I think 1:15, 1 something. I don't
Mhm.
know.
So pop back on if y'all got a question, all right?
Okay, thank you.
quick question.
Thank
do we
you.
have to use this link to hop back on, or is it like a separate link?
Say again now.
I said, do we use this link to hop in for the
Yeah,
help?
yeah,
or-
same link.
Same link. Okay.
What I'm gonna do is I'm gonna shut this one down so that I can get my video ready for y'all and send that out. And then I'm gonna reopen it. And if you need me, pop back on, okay?
Okay, thank you.
All righty, y'all. I'll see y'all later. If y'all don't pop back on, I'll see y'all tomorrow.
Mhm.
Bye.
Bye-bye.